Okay, class, this is a very short video. It's on the rule of 100. That's what the quiz is going to be based on for Tuesday. There's nothing out of the ordinary for this. There's not going to be any trick questions. You're going to have probably two questions only. Very first question, you won't have to use, you won't have to use a quadratic equation because the rule of 100 is going to be greater than 100. And then the second question, it's going to be less than 100. You're going to have to use a quadratic equation. There are no tricks, nothing that you haven't seen before. All you have to do is practice. If you did those 6 questions that were assigned on Friday for homework, you should be okay. Okay, so very first example right here, balanced chemical equation, 2NOCl, 2NO, and Cl2. You're given an initial quantity of 12, let's say this is moles, and that means you have no product. So just using an ice table, nothing special here, lose 2 moles here, gain 2 moles of NO, and gain 1 mole of Cl2. So your final equations here are 12 minus 2x, 2x, and x. Now you can substitute these equilibrium activities or values into equilibrium expression. So that's given here. So this is NO squared times Cl. Remember, these are concentrations that we're measuring. Products over reactants, right? So let me put this here just in case anybody doesn't remember. K equals products over reactants. So K value is given here as 4 times 10 to the negative 11. K is a really small value. That should give you a big hint. If K is really small, very likely you don't have to use quadratic equation. So here we just put the E values or equilibrium values that we had. So 2x squared, please don't forget your exponents, times x over 12 minus 2x, and this is squared because we had 2 moles of it to begin with. So over here you notice we went from 12 minus 2x to just 12. And that's because we can test that assumption by using the rule of 100, which is taking the initial concentration that we had, which was 12, and then dividing by the K value, which is really small. And what this means is when you calculate it and we got a value that was much greater than 100, it tells us that we can drop that minus x. Is going to be so insignificant it doesn't matter. So we go from 12 minus 2x to just 12. This makes the math a lot easier because now you can just cross multiply here and here, and you get an x value after you cube root it of 1.13 times 10 to the negative 3, which is roughly 0.00113, which is really small. Now we made an assumption here that because this value was greater than 100, we could drop x. If we substitute x back into original equation, we'll notice it doesn't really change much. Okay, so we have 12 minus 2x, x here being 0.00113. We get 11.98, which is honestly close to 12. That's close enough. We have a difference of 0.17%. Cutoff for significant figures is 5%. So 0.17, well under 5%. That was a valid assumption. Please, on the quiz, if you use this assumption, write down that why you used this assumption, that it was less than 5%. So that's one type of question. Now obviously there's only one other type of question left, which is where you have a big K value. If you have a big K value and you divide your concentration, so let's say it was 12 again, and let's say this time our equilibrium value K was given to be 6. So that equals 2. That is much less than 100. So now you have to use the quadratic equation. That's the only way the question is going to be set up. The concentrations and the x values will be set up in such a way that you're going to get a quadratic equation. So it's going to be in the form of ax squared plus bx plus c. And then you can just make it all equal to 0. Use these numbers here, these coefficients here, in your equation for the quadratic equation. Remember, you will get two x values because it's going to be negative b plus something and negative b minus something. If you have two values that are positive, then you have to choose the value that makes sense. So there's going to be one value that will fit, and there's going to be another value that's going to be much bigger. So let's say our initial concentration was 12, and we ended up with minus 2x. If you have an x value of, let's say, 7, 2 times 7 will be 14. You can't have 12 minus 14. It's just not going to work. So even though that x value is positive, it's not a logical x value to put in. The other x value that you will get will be a number that will fit within this range. So let's say we got 5 for x. Then it's going to be 12 minus 2x, or 2 times 5, which will equal to 2. This value makes sense because you can get a negative number at the end. The other scenario will be you have one positive number and one negative number. In that case, you just take the positive number because the negative number will not work. It does not make mathematical sense, so you will always stick with the positive number. I haven't put an example over here because there are 6 examples in your textbook. The very last 2 that I put for homework, they deal specifically with the quadratic equation. If you do those 2, you will be fine. Trust me. Just get enough practice with these equations so that you know what to do. I found that many of you don't have problem with the theory. Theory is fine for you, but when it comes to actual calculations, just putting numbers into the calculator, that's where a lot of you are getting lost. Please, please, please do your homework, practice it, do the questions twice if you have to, just be accustomed to it. Good luck on Tuesday.